welcome to the statics tutorials. So we have a beam here that's supported on this end with a smooth frictionless pin at A, and this end with a roller, smooth frictionless roller at B. And we're going to draw the shear and bending moment diagrams for the beam. Here's our free body diagram. We need to solve for those reactions first. So sum of forces in the x equals 0 gives us that AX is equal to 0. Sum of forces in the y equals 0 give us just AY and BY in this equation. The moment doesn't show up in the equation because remember, with the couple moment, it's going to be two forces that are equal and opposite. So those two forces add together and give you no net force. So we solve and wind up with the result that AY is equal to negative BY. Then we can do our sum of moments about A. The 100 kilonewton meter moment there is negative, so we have the negative 100 kilonewton meters, and then we have plus BY times the 2 meter length here. So we get that BY is equal to positive 50 kilonewtons, and AY is negative 50 kilonewtons. So now we can draw our shear and bending moment diagrams. So we'll start here with our shear, and then we'll account for the reaction. So we're going to start at 0. We account for the reaction at the end, which is negative 50. So it's going to bring us down to negative 50. Then we look back at the beam and we see if there's a distributed load. We don't have any distributed load, so this tells us that our slope is going to be 0. So we continue on with the 0 slope all the way across until we hit the negative 100 kilonewton meter moment. But remember, a moment again is a force in one direction and an equal and opposite force just separated by a distance. And so this moment contributes 0 net to the shear. So even though there's this couple moment here, the shear just goes on across with that same 0 slope until we get over here at B, and then we have this 50 kilonewton force at B. We're at negative 50, so then that brings us back to 0. So we've been able to account for all of the shear forces. Let's take a look then at our bending moment diagram. So with our bending moment, we start at 0. We take a look up here and we see if we have any couple moments in this first part of the beam, maybe due to a reaction or due to an applied couple moment, and we don't have any. So this means that the bending moment's going to start at 0, and it's going to have the slope of whatever our shear is at that value. We have a negative 50 shear, so this says our bending moment starts at 0, and it's going to come down with a constant negative 50 kilonewton per meter slope. We go over 1 meter, and so that brings us down to negative 50 kilonewton meters. You can see here when we calculate the area of this first rectangle up to the moment, that the area is negative 50 kilonewton meters, and that's that same drop that we have here. Now we're going to add in the bending moment, the 100 kilonewton meter into the bending moment. So this moment's negative. Remember, with moments, we first flip the sign before we add them in. So we have negative 100 kilonewton meters. We flip the sign and it becomes positive. So we have negative 50 plus 100 brings us up to 50. And then we're going to, again, look at the shear and see that we have that negative 50 slope. And so we're going to come down with that negative 50 slope. We're going to drop the same area, negative 50 kilonewton meters, and then we're going to wind up back at 0. So we've been able to account for all of the bending moment. Thanks for watching.